A lot of people understand that XGBoost adds trees one after another to fix errors. But when you actually give the model a new input, what exactly happens? Which branch does it take? Which leaf does it land on? What number does that leaf contribute? And how do multiple trees combine into one final prediction? In this video, we'll trace a real example all the way through. We'll use the same energy demand problem from the last video. Follow one temperature through each tree step by step and compute the exact predicted power at the end. By the end, you'll not just understand how XGBoost is trained, you'll understand how it makes a prediction. Welcome to Schovia Labs, where we turn AI concepts into everyday ideas. In the last video, we built intuition for how XGBoost trains. We started with a baseline prediction, built a first tree from residuals, applied learning rate, and then built more trees to correct what was still wrong. We also touched on stopping rules and regularization. But a natural question came up in the comments. Once the trees are built, how does the model actually predict for a specific temperature? That is what this video is about. Let's quickly recall the data set from the previous video. We were predicting building energy demand based on outside temperature. The data looked like this. And the first thing we did was compute the baseline prediction, which was the mean power consumed. Then we calculated residuals. Then we tested candidate splits and found that the best root split was at 7.5. After that, the right child was split again at 37.5, giving us a depth 2 tree. So now we already have the first trained tree, and because XGBoost is a sequence of trees, we'll also use the next tree that was trained to correct what the first tree still got wrong. Once these trees are trained, how does a model make a prediction? Here is the key idea. The trained XGBoost model makes a prediction by following these steps. Start with the baseline prediction. Send the input down the tree. Add the leaf correction for the region where the input lands. Then send the same input down tree 2 and add tree 2's correction. If you have an XGBoost model that contains n trees, you add the contribution from all of them. And that is it. So let's now bring back the same tree from the previous video and let's walk through a full prediction. Suppose the outside temperature is 4 degrees. We start with the baseline, 8.8. Now send 4 through the tree. And the first question is 4 less than or equal to 7.5? Yes, so we go to the left and land in the left leaf. That leaf has a correction of plus 3.70. So the model's prediction is 12.5. So for a temperature of 4 degrees, the predicted power is 12.50. But in a true tree boosted example, we do not stop there. We now send the same input 4 degrees through tree 2. In tree 2, 4 is not less than or equal to 2.5, so it goes right. 4 is less than or equal to 32.5, so it goes left. And that lands us in the leaf with a correction of negative 1.0528. So the full 2-tree prediction is 11.4472. And if you add learning rate to it, where let's assume that it's equal to 0.5, the final prediction is 10.1236. So if we include the learning rate, eta, at 0.5, XGBoost predicts an energy demand of 10.123 when the outside temperature is 4 degrees. Note that the correction at each leaf does not have to be positive. It can be negative as well, and it depends on where your sample lands. Individual decision trees of XGBoost do something very simple. At each split, they ask a threshold question. Those are the only decisions that are happening inside the tree during prediction time. The model is not relearning anything. At prediction time, the trained tree is just applying the learned rules. Now let's zoom out. A single tree gives us one correction, but XGBoost is not just one tree. It uses all the trees, one after another, and sums their contributions. This is a crucial distinction from the way many beginners imagine tree models. The full model is not one giant tree. It is the accumulated output of many small trees. So that is how XGBoost turns an input temperature into a predicted power value. Start from the baseline, pass the same input through each tree, collect the leaf corrections, and add them all together. If this made XGBoost feel more intuitive, subscribe to Schovia Labs for more machine learning deep dives. And as always, stay curious.